Welcome to my Module 5 experiment for the Physics 1010 class, where today we will be trying to measure the value of the gravitational field strength G using a simple homemade pendulum. Now, I've taken a string, to grade my pendulum, I've taken a string and on one end I've attached a hex nut, and on the other end I've taped the string on the ceiling with some tape. Now, I've measured this strength before I attach them on the ceiling to be 50 centimeters. I'm gonna be remeasuring it since the hex nut might be pulling on the string and extending it, which doesn't seem to be significant enough here as it is still reading a value of 50 centimeters. So the length of the string is 50 centimeters. We're gonna be using a timer at the bottom of the screen to determine the time taken for the pendulum to make 10 swings. And we will divide that later by 10 to find the period of the pendulum's oscillatory motion. Now, how will this help us find the gravitational field strength? For small angles between the string and the vertical line, the gravitational field strength is given by the equation G is equal to 4 pi squared times the length of the string over the square of the period of the oscillation. Now, with that said, we're going to be taking this hex nut and we're going to be pulling it on the side. And we are going to be releasing it in 3, 2, 1. 3, 4, 5, 6, 7, 8, 9, 10. And that's gonna be our value for the time for this pendulum to make 10 swings for a length of 50 centimeters. Now that we're done with the first trial, we're going to be doing 2 more trials where we're going to be looking at the pendulum when it has different lengths for a string. As like before, I've measured this so that it should be 80 centimeters. I'm going to quickly check. Yes, it is 80 centimeters. And just like before, we have a timer at the bottom and we're going to be measuring the time that it takes for the pendulum to do 10 swings. So 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that's going to be our time. Now we're going to be doing the next trial. For our third and final experiment, we are going to be increasing the length of the string to should be 110 centimeters. Let me go ahead and check over here. Yes, it is 110 centimeters. And as always, we're going to have a timer at the bottom. And we are going to be measuring the amount of time it takes for the pendulum to do 10 swings. So 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And with that done, we are going to be using these time values that we measured to calculate the gravitational field strength. Now that we've finished obtaining our values from our experiment, it is time to do some analysis. So here we have a table where we've separated our values based on which trial we have gathered them from. So for trial 1, that's describing the trial for when the length of the string is 0.500 meters. Trial 2, we have that the length of the string is 0.800 meters. And trial 3, we have that the length of the string is 1.100 meters. We have the time for 10 swings for each of the trials. And to calculate the period of the pendulum's oscillatory motion, we have divided the time for 10 swings by 10. So for example, for the first trial, we have 14.41 seconds divided by 10, which gives us 1.441 seconds. Remembering the formula for the
gravitational field strength. That would be 4 times 3.14 squared, the value of pi here is given to us by the teacher, times 0.500 meters over, all of that over 1.441 seconds squared, which gives us a value of 9.50. We've repeated the same calculations for the rest of the trials. So for the second trial, we have 9.59 meters per second squared. And for the third trial, we have 9.71 meters per second squared. We have calculated the average of these values to try and get a somewhat accurate, more accurate answer. And we found that the mean of the strength of the gravitational field is 9.60 meters per second squared, which we have found simply by adding all of the values of the strength of the gravitational field and then divided it by 3. To find how much variance there is, we have calculated the standard deviation of the 3 values. The standard deviation would be the square root of the sum of the squares of the difference between the individual values and the mean of all the values, all of that divided by the count, which in this case will be 3. And what we find is that the standard deviation for these values is 0.09 meters per second squared. Since this is a relatively low standard deviation when you compare it to the mean, it means that the variation we got for the value g is relatively small. As such, we can reasonably conclude that the strength of Earth's gravitational field in my house is 9.60 meters per second squared. With all of that said, there are some possible sources of error for our experiment. Some of this include the effects of the force due to air resistance that can affect the object's speed, and the difficulty of swinging the pendulum with an angle that's close to 0 degrees. This can help explain the variation in our results. With better equipment, one can surely obtain a more accurate value for g. Thanks for coming to my physics video, and I'll see you next time.